I'm not trying to ruin anything.
Hey everybody, sorry I am a minute late. As you could tell from my email this morning, things are a little crazy in my house right now. So yes, we will be on Zoom for the foreseeable future. probably just through next week, depending. And we'll just do the best that we can. I came up with some hacks for how we can do some of the things we typically do. When we go to do activities, I can just share them as Google Docs, so we can make it work. I think we can, and we can get through everything together. So thank you again for being flexible and understanding. And I am just pulling up the participant list so that I can take attendance. I know some people are having some technical difficulties, so hopefully that will not continue to be the case. And just checking everybody off here. Thank you for being here, and thank you for sticking with me through what is not what we expected, obviously. So we are super careful. And basically what happened is a parent of a child in my daughter's classroom tested positive, but still sent their child to school. So, and 3-year-olds aren't particularly good at wearing masks. So this is what happened.
Sounds like a lawsuit.
I know, I kind of, yeah.
Like, especially if like one of the kids gets it and has
Bad
like,
symptoms.
problems, that's a lawsuit.
Yeah. So her whole school is closed now because of it. Initially, they were just doing her classroom, but now the whole school is closed. Other kids in her class have tested positive sometime later today. If I get the call during class, I'll probably pick it up. So apologies in advance, but I'm waiting to hear from her doctor's office about her results. And yeah, just gonna do the best I can. And again, thank you all for being flexible. I would love to be back in person with you sooner rather than later. But you know, we've got to do, it's my husband's doctor, my doctor, and Quinn's doctor have all told us like quarantine for 10 days. So we do have to, you know, do that. And I would do that anyway, just because I want to keep y'all safe. Right after our class, I'm going to go get my brain touched again and see if I am also positive. I do know a friend who her husband and children got it and she never got tested positive. So fingers crossed that'll happen for me. Is we are all well, my husband and I are vaccinated. The problem is he had Pfizer and I had Moderna, so he's getting the symptoms because it's a little less effective against the Delta variant. So yeehaw. So today we're going to keep going with our lecture, but the first thing that we're going to do actually is I want to try to do the activity I would normally do in class, which is where I would have you all write your heights on the board and we would calculate everything. So let me go ahead and share this document. I'll get the link. I created a Google Sheet for you to enter in your heights. And we're just doing initials, not name. I mean, if you don't care if people know your height, you can write your name up there. Let me share a screen so you know what you're looking for here. There it is. Okay. Okay. So as you can see, I put in my height here. And this last row should just, if you put in like I'm 5'4", so I put in 5 and then 4, height I feet. Yeah, that's a thing. There we go, height feet. That it should convert it to inches overall for you. Like that. Awesome. So once everybody has their data in, we'll go ahead and we'll play around with the numbers together. And while y'all are doing that, I am going to just make sure I have the chat open in case anyone wants to ask a question that way. And also making sure I am giving everybody who is here credit for attendance. So again, if you haven't done it yet, follow this link and go ahead and put in your height, feet and inches, and then the formula will convert it for you. And then we'll go through essentially the process we went through on Wednesday, but just with our new data. And believe it or not, this is pretty comparable to the time it would take in class, because typically I have people come up and write their heights on the board. So this is pretty comparable to that. Again, I'm trying to replicate the process of class as much as I can this way. Also, while you're putting those in, I'll let you know I'm going to grade your exams over the weekend. So you should have your scores about a week out from when you took it. So thank you to everyone who has emailed me your take home if you weren't able to turn it in the day of the exam. If you haven't done that yet, please do so that I can grade it all together. All righty. Looks like we've got some good data here. All righty, and so we can see we're actually pretty clumped together. Sometimes I've had more extremes. I think I had a time where I actually had someone under 5 foot. So, you know, we're all within 12 inches or so of each other, which is fine. All right, so it looks like maybe our lowest height is basically my height. Oh, a couple of people are still entering them. Awesome, right? All right, so what we're going to start with is doing class intervals. And so that's what I'm going to use this data for. And so, sorry, just, I don't know if y'all would be able to see. On our banister right here, Simba's walking it like a tightrope right now. So it kind of distracted me. So looks like our lowest height is my height, which is 64 inches, right? So that is our lowest. And I'll just type on here so everyone can essentially see my work. And then it looks like our highest height is 72 inches. So someone who is exactly 6 foot. Cool. So in order to figure out intervals for height, we would subtract 64 from 72. So I will just pull up a calculator here. I know Excel could do it for me, but I am gonna just try to show you the actual process. There's a great, yep, there it is, online calculator called Web 2.0 Calc. Okay, so we got 72 minus 64. Okay, so that gives us 8. We only have a span of 8. So 8 inches in between. And then let's say we do want to do 4 groups, right? So then we would just have, for 4 groups or 4 class intervals. And we would have basically 2 people within each, right? So we'd go 64 to 65, 5 to 66. And I did this wrong somehow, guys. I'm sorry. It's a day where my brain isn't working. So then let's say we wanted 5. That's fine. Okay. So then what we would do is we would just look and see how many folks here we have at each one. So from the height of 64 to 65. We've got 1, 2, 3.
You have 65 on there twice.
Ah, that would be why. Thank you. Told you my brain isn't working. So, there we go. Thank you, Debbie. And then we could just do this. There, that makes a lot more sense, y'all. All right. So the people who are 64 to 65 page. And this person is going to be, I don't know why the formula didn't work, but this person's going to be 6600. So we've got 1, 2, 3 people who are between that interval, right? And then if we look at 66 to 67, we've got 1, 2 people there. 68 to 69. Looks like we've only got 1 person in that range. And then actually we have a decent number of, we'll just make this 70 to 72, of tall people. So we've got 1, 2, 3, 4. No tall people in our class. Okay, so then were we to make a histogram, I know Excel would make it for me, right? But I'm going to try to demonstrate it for y'all here, right? So I would do, okay, so here is, if the y-axis becomes the number of people, right? So here's 4, 2, 4, 3, 2, 1. There's our 0. And then over here, I would put my class intervals, 54 to 65, and 66 to 67, 68 to 69, and 70 to 72. Okay. And then again, I would be drawing this, but I'm just going to approximate it for y'all with what Excel would, what it looks like drawing. So I'll just make them black. Okay. So we have 3 people in the first one. And then we have 2 people in the second one. This is as if I was coloring it in my hand, right? And then we only have 1 person here. And then we had 4 in our last group. So that's what our histogram would look like for this data that we collected from our heights. And again, were we to make a frequency polygon instead, we would just have dots in the middle of where each of these columns are, and then we would connect the dots. So hopefully that helps make it make a little more sense. I think sometimes seeing something done again can be helpful. All righty. So we left off talking about percentile rank. So let me go ahead and present this with our captions as usual. And I am just, sorry, I'm getting a lot of text. I'm just making sure, nope, none of them are from my daughter's doctor. So just checking. And so we left off here because this is fairly complicated and I didn't want to squeeze it in at the end of class the other day. So the percentile rank allows us to ask what % of the scores fall below a particular score. And in this case, they designate it as XI, right? But you could call that score whatever you want to call it. You could call it red triangle if you wanted, right? XI is just a symbol we're substituting in for the actual score. So what we would do is we choose that XI, we choose that score. So let's say we want to see how many people fall below the 50th percentile. So we're going to use 50 here. And we would determine how many cases are in the group. And then we would divide the number of cases below the score of interest that we got from step 1 by the total number of cases here, which would be step 2. And then you get to multiply that by 100, and that gives you your percentile. And so here you can see the formula. So if we want to use our height data, So again, I'll kind of switch back over here. First, what we would do is we would take this data and rearrange it. And I do this pretty easily in Excel, which is nice. Sort this by column D. Okay. So there we have all of our heights now in essentially shortest to tallest order. Sometimes for percentile rank, actually, it's helpful to look at it the other way. So let me go ahead and do it tallest to shortest. And all I'm doing is just telling Excel to sort it. Well, in this case, Google Sheets to sort it. Okay, so there we go. So let's say we wanted to figure out how many cases fall under the 50th percentile for height in our case here. So again, we have really a short range of inches, right? So we would say, okay, so we've got our, let me flip over here, our 72 minus 64 is 8, right? We want to get to the 50th percentile of that. It's going to be, 4 inches up, right? So we go 4 inches up from 64, we would go 65, 66, 67, right? So essentially this is our cutoff for our 50th percentile, okay? So we would say, all right, so we've got 1, 2, 3, 4, 5 people. 5 people under 50th percent. Okay, and then we've got 10 people actually in our data set. Okay, so then what we would do is we take our answer from step 1 of how many cases fall below what we have of interest, so 4, and then how many cases are in the group, 10, right? So if we were to divide 4 by 10, that gives us 0.40, right? And then to make it a percentile, we just multiply it by 100, and that gives us 40%. So 40% of the people in our class fall below the 50th percentile for height in our class. Again, for something like height, this seems a little silly, right? For grown people. Actually, when kiddos are growing up, this is pretty important, and they look at this quite a bit to make sure that kids are growing at the proper rate, and they have charts based on the average heights and weights of kids across the spectrum, right? And they can show you where your kiddo falls on that. So my daughter has always been above the 90th percentile. She's just very tall. We don't know why. I'm not tall. As we saw, I'm at the bottom of our percentile. My husband's not really tall. So she's been at, the 99th percentile for someone her height. This past year when we went in, she was actually at the 50th percentile for someone a year older than her. So, it can give you some interesting information that way. And so if a child isn't growing, for example, on the curve that we expect, then the doctor might check nutritional values, check to see if they're not processing food the correct way, things along those lines. Again, where we're gonna see these used more often actually tend to be things like standardized tests, right? So again, taking standardized tests as a kid, you may have gotten results of like you were in the 76th percentile or whatever, and it just means you did better than 76% of other people. Alrighty, so this is probably something you've learned about in math class, but it may have been a minute, so you might be a little rusty on it. So we're going to talk about normal and skewed curves. So the normal curve follows the natural laws of the universe, which is true. Like essentially through the laws of probability, we do, if we kind of divide at that 50th percentile we were just looking at, we tend to have beings, whether they be people, animals, plants, whatever we're examining, that fall on either side of sort of the average score in about equal amounts. And it tends to follow this bell curve for most things in nature. So instead of looking at our small sample today of 10 people with our heights, we looked at height overall for the population. What we'd find is that we do have equal people on either side of what that average height is. And that they sort of peter out at the extremes, right? You know, NBA basketball players being the extreme for height. You know, people with height development disorders at the small end. I don't know what the political correct term is, if they've reappropriated dwarfism or not yet. So this will come into play a lot as we go through this lecture, probably into next week, and we talk about z-scores. So just sort of like keep this in the back of your head. So there's this, what's called rule number 2. And this is a quote from Einstein where he says, God does not play dice with the universe. So the universe and natural phenomenon in general do tend to sort of follow things in this natural way. But it is possible to have skewed curves that can be skewed in either direction, where you're going to have scores sort of clump either at the high or the low end of the graph. So positively skewed means the majority of scores are going to fall near the lower end of the graph. And then negatively skewed means the majority of the scores fall near the upper end. So unlike the normal curve, neither one of those are going to have the same amount of people on both ends. So again, positive are where the majority of scores fall near the low end. Negative are where the majority of the scores fall on the upper end. We also like to, we've been looking just at distribution of scores, and that can be helpful to get an overall picture. So for example, last night we did a webinar about COVID-19 in kiddos. And we realized pretty quickly it wasn't for us. It was for people who, did not believe in the vaccine. We just wanted to know when we might be able to get the vaccine for our kiddo. But so this is a chart they showed of the COVID cases in Virginia. Okay. So as you can see, this is skewed, right? It is negatively skewed. Most of the scores, unfortunately, falling near the upper end here, and the upper end being closer to today, right? And that can be helpful to look at overall, but sometimes it's more helpful to look at what is happening sort of overall with the scores. And these are called measures of central tendency. So basically, what's happening overall, what's happening in the middle, what's happening with the most people. So these tell you something about the center of a series of scores, and there are different ways of looking at what that center might mean. And so you have mean, median, and mode. And so depending on the type of curve you're looking at, your mean, your median, and mode may or may not actually be the same number. So again, if you have your book and you flip to page 119, they have a nice little diagram here. Again, I'll try to hold it up to my camera, where you can see if you are in fact on a normal curve, the mean, the median, and the mode are all the same number. But as soon as it starts to get skewed, those are different. And Simba came to say hi. With a sit right on my notes. Oh, that's so helpful. Thank you. Sorry, it's the obstacles of teaching at home include cats. So basically, as soon as you get away from the normal curve, the mean, the median, and the mode differing will actually tell you some interesting information about the data. All right, so the median is the middle score. So if you were to just take your data, divide it down the middle, what score falls in the middle? And then whether you had 5 data points or whether you had 1,000 data points, you can do this. There are ways to figure this out. If you have an odd number of scores, so it's 5 or 1,001, you can pick the score that's exactly in the middle, right? And this would be just like we did on our Google sheet of heights, where we would actually order them biggest to smallest, and then it's that number that actually falls in the middle of everything. If it is an even number, you take the 2 scores that fall on either side of what would be the middle, right? So let's say we're looking at a sample size of 6. Then those 2 scores would be the third person and the fourth, right? So there are 2 scores you would average, and that would give you your median for that data set. The mode is just the score that occurs most frequently. So in our he's just giving me this look. In our height data, if we looked at those class intervals, what we would see is that our modal one was the tall people, right? That had the most people who scored that. For a mode and larger data sets, you're typically looking at actually the number that occurred most frequently. So that might be, again, the mean, or it might be a lot of people scored 0, right? That can happen. And then the mean is the average. Mean is just the average. So you just add up all the scores and you divide them by the number of existing scores. And so that's what this fancy formula right here says. So the X with a bar over it represents the mean. That's the typical way we represent the mean. And then this fancy thing, again, if you're rusty on math, just this thing that looks like a E is just means sum. So you would sum all the values of X. So we'll do this in a minute with our heights. We would just add up all the heights, and then you divide it by the number of participants. So we would divide it by our number of people. So we use these things. We use the mean, the mode, the median to help summarize information about the data set. And sometimes, again, we have these huge data sets. If you have 1,000 people, it's a lot harder to just eyeball it, right? So things like this give us quick information about this. And the nice thing is statistical programs like SPSS, which we'll learn about later in the semester, will actually just do this for you. Which, again, even if you have a big data set, is usually like that. So if you look at table 6.4 in your book, again, this is page 118, it shows you an illustration of what the mean, the median, and the mode are for various data sets and how you would get at them. So let's go ahead and walk back over to our height data set here. All right, and we're obviously not going to use the people who didn't show up. I'll just go ahead and delete those. Okay, and so were we to do this by hand, we would actually add all these up because I want to be as efficient as possible. I'm just going to highlight them, and in Google Sheets, if I look down here in this corner, it will tell me the sum, which is really cool. I could also do a formula to have it tell me the sum. But I can say from right here that the sum of all of our heights is 680, okay? And then we already established that we have 10 participants, okay? So then we would just divide 680 by 10. That one's easy. I don't actually need my calculator, right? So this is the sum of heights. Yes, you will be doing this with scientific calculators. This is the big thing you'll do with your scientific calculators. The sum, and so like your next assignment, which we'll probably get to Monday, we'll be doing this exact thing actually. And we'll do it in class so you can ask questions. So then we have the sum of heights, we have the number of data points, And then that gives us our mean height. And again, if we were in class, I'd actually like write this out on the board, but hopefully this is illustrating it in at least a way that can be somewhat helpful to y'all. And again, hopefully in 10 days, I'll be able to be back in class with y'all, no problem. The next thing we're going to talk about is measures of variability. So in addition to knowing sort of where the middle score is, we want more information typically about data. We want to be able to say, okay, so this is like what the middle of the data set looks like, but you know, you can have a mean of a height of 68 inches, 5'8", right? And it doesn't tell you that much if you don't know anything else, right? It could be you have a height average of 5'8" because you're looking at the Rockettes. So if you're not familiar with them, they're in Rockefeller Center at Christmas time. They're the people who do all the kicks. And in order to be a Rockette, I believe your height has to be between like 5'8" and 5'10". They're very strict on height because they want the line to all be the same. So, you know, if you had that versus, you know, a class of people like us, right? It's not going to tell you as much about how much our height is going to vary, even though we might have the same average height. So then we have these measures of variability that tell us even more about the scores. So there are 3 types of variability that we look at. The range is what we've already looked at. It's just the highest score to the lowest score plus 1. The interquartile range we'll talk about on the next slide. And then we'll also have a slide where we look at standard deviation. And standard deviation is the one that if you're reading something that talks about statistics, the one you will typically see most often. So typically when you see statistics reported, you will see a mean and a standard deviation for a particular variable or set of scores. Alrighty, so the interquartile range looks at the middle 50% of scores around the median. So again, if you look in your book, I keep putting mine in different spots. This is page 120, and it is a figure 6.7. It shows you essentially they're just, if we divided the data set into 4s, this is the interquartile range. It is the 2 around the median. So basically the middle of your data, right? And again, if we're looking at it on a normal curve, it would look a lot cleaner than it does on skewed data. So if we use numbers, and these are the numbers from the example we were using on Wednesday of the numbers that were given in the book, then we would use this formula, and is the number of scores, and then you round off and you find that specific score. So again, if you look at the table, 6.5 on page 121, it basically shows you they broke down where that interquartile range exists on the data. So I'm not going to like dwell on this because I have to tell you, in the, at this point, probably 20 years that I've been working with psych statistics, I've literally never looked at an interquartile range. It's just, it's something that we might look at on like a table, but I've never ever calculated this. So I'm not going to make y'all calculate it either, but it's just something that it's good to know it exists and some people do use it. The standard deviation, as I said, is something that you are going to see and we are going to look at quite a bit. So even if you're just reading a research article, standard deviation is going to exist in there, but especially when we start to look at groups of people who have taken these assessments, right, and trying to determine whether the assessment's good or not, and the normative sample. They're going to be reporting means and standard deviation. So it's good to understand what this means. So you can easily apply this to the normal curve. This is the one change on this that I missed. So apologies for that. So it should be figure 6.9 and the page number is 124. I'll change that real quick. The one update I missed here. Okay. Okay. So you can see essentially what the standard deviation is. The standard deviation is, equal across a normal curve. But again, gonna get a little fancier when we talk about curves that are not normal. But as you can see, many human traits do approximate the normal curve. So, that does make things helpful. So really what we're looking at when we're looking at standard deviation is the variability of the sample. So it's basically the average deviation from that mean score. So how much does the average participant in our data set differ from that mean? That's what the standard deviation is telling you. So basically, standard deviation is this formula. So again, remember this fancy symbol here just means you're going to add all those things up. So you're going to take the person's individual score and subtract the mean from it. So obviously this means that sometimes you get a negative number, which is why we square it so that it's positive. And then once you add all those up, you divide by the number of participants you have, and then you take the square root. So this is that formula. So it's the square root of the average squared deviation around the mean, which is just a really fancy way of saying this is how we calculate standard deviation. So this is the initial formula you typically look at when you are looking at learning about standard deviation. And this shows you how you get to those numbers. So again, let's say these are data we've collected. These are all of the people's scores, X. So this would be, person 1, person 2, person 3. Okay. For each one, we're going to take that number and take the mean away. And so they've calculated the mean by saying, okay, there are 80 people, 80 is the sum, and we've divided it by 10 people. Okay, so that's how they got the 8 for the mean. And so then again, you're going to subtract each one here. And so then, 12 minus 8 is 4, you square that, 16. 11 minus 8 is 3, you square that, 9, right? And down here, 5 minus 8 would actually be -3, but when you square it, it becomes a positive 9, right? And so then you add up all those squares, right? And some of them will be 0, because if it's 8 and your mean is 8, there you go. Okay, so they're X minus mean squared. So here's your X minus the mean, and then this is when you take the X minus the mean and you square it, okay? In this case, the sum of that is 88. So what all this table just did was to give us that top number in that formula. So it just gave us this right here. Okay, so then what we would do is we would say, okay, so we're going to take that number we just figured out, that 88, and divide it by n. And n in this case is 10. There were 10 numbers in the data set. Again, if we go back and we look at this data set, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, that's how we got our mean initially. We took the sum of these numbers, which was 80. We divided it by our number of people, 10. That got us our mean, right? And then we plug that in over here too. So our sum of that squared number, right, is 88. Divide that by 10. Okay, and that gives us 8.8. And for some reason the square root symbol moved. It should be there. The joys of Google Slides. And that gives us 2.96 if we were to take the square root of 8.8. So that 2.96, that is our standard deviation. So measures of central tendency and variability helps us to understand essentially the data as a whole, and also to understand where a person falls relative to the peer group, right? But we need to remember that that can be variable in different ways and for different reasons. And we also need to remember the person, particularly for thinking that eventually we're going to be applying these numbers to figure out the scores of real life people who would sit across from us as we gave them an assessment, right? That's why I'm teaching you all this math, is so that you would understand if you had to, you know, again, make something of the raw scores you get from a person in front of you, right? So how that person feels about where they're falling in relation to their peer group is always, always critical. And so this will actually be really important, again, when you give the person feedback, right? So I'm telling them what their test results tell us, right? If our test results tell them, you know, you have a learning disability, or compared to your peers, you're not as good at, you know, maintaining your attention. For some people, it will be a relief. Oh, good. I finally know what's actually going on with me, right? For other people, it will feel like a blow to their sense of identity, like there's something broken or wrong about me. And then going forward, that could actually lead to differences in how they'll perform on other assessments in the future. Even something as simple as a test in class, right? So if they internalize that and they say, oh, I have a learning disability, that means I'm stupid, they might not try as much. So part of your job as a clinician is to put that into context for them. Okay, here are the numbers. Here's what they mean. Here's what this actually means for your life, right? Is that you need to take certain precautions, right? Or certain steps to kind of put yourself on the same playing field as everybody else. But it doesn't mean that you can't perform as well as anybody else, right? It means that with those precautions, with those additional measures, maybe extra time on a test or things along those lines, you will do really well. And in fact, now that we have these numbers, it means we can help you, right? So part of your job as the person who relays this to that individual in front of you is to put it in context for them and to give it that realistic but optimistic spin. All right, so I'm going to stop there because sampling people is sort of a different subset of things that we will talk about. So thank you again for your flexibility. And I will see you all on Monday. Take care of yourselves.
Okay, so I do have a question about when I took stat at TCC.